This video calculator will help you check your solutions. And this doesn't have to be for logarithmic equations like the one that I'm showing here on the screen. It can be for any algebraic solution that you find. Two ways in which you can choose to check your solutions. First, you can see that I have certainly solved this logarithmic equation by using the property of equality of logarithms, and we come down and I found that x is equal to 9. So I'm going to go into my calculator and I'm going to say 9 store to x and enter. Now that value of 9 is stored as x. I'm going to enter the left-hand side of the equation, the natural log 5x plus 9, close that parenthesis to end the argument, minus natural log x, close that parenthesis, hit enter. That left-hand side of the equation is 1.791759, etc. I'm going to compare that to the right-hand side. So the natural log of 6, close parenthesis and enter, and sure enough, it's the exact same value. So I'm assured that my solution of 9 as x is correct. Another way to check your solutions is by use of your grapher. On y1, I'm going to enter the natural log 5x plus 1 plus 9, close that parenthesis, minus the natural log of x, close that parenthesis. That again is the left-hand side. I'll go down to y2, enter the right-hand side, the natural log of 6, and close that parenthesis. I'm going to go ahead and check. I don't know what my window's set, so I'm going to start at a standard window of 6 and graph those two functions. And I can see that it does intersect somewhere here, but it almost looks like they come the same line. They're not. So I'd like to see this part better. I have a whole lot of wasted space out here. I'm going to go in and change my window. I'm going to let x be from -2. I'm going to leave it to 10 because I know I need x is 9 as my solution, or I think that's the correct solution. Down here at my y, I'm going to say from -2, and I'm going to go up to a +3. Changing my window and then hitting my graph. It's like I've used a camera to zoom in on where that intersection point. So I know it intersects somewhere here. I'm not going to use the trace because I can't get the exact intersection. And even if I go to table, it's going to be almost impossible to see that exact intersection. Because it's such a long decimal there. So instead, on my graph, I'm going to use second, calculate, and I'm going to go to number 5, intersect. You can see that I'm on y1. You can see my cursors on that function. I'll hit enter. It automatically drops to the second function. You can see the cursor there. I'll hit enter. Guess, yes, I want to find the intersection for those two functions. And when I do that, of course, I find, in fact, that 9 and y is 1.7175. And that is exactly what happened back when we checked it, when we stored that value for x. So I've double checked that my solution of x is 9 is correct and verified that.